Science on the Menu, a podcast by the European Food Safety Authority.
Hello everyone, and welcome back to Science on the Menu, a podcast produced by EFSA, the European Food Safety Authority. This is Barbara Ghizzoni, team leader of the digital publishing team in EFSA, and today I'm joined for a very important discussion by our climate change expert, Angelo Maggiore, scientist in the Knowledge and Innovation Unit in EFSA. Hi Angelo, how are you?
Good morning everybody, I'm very well. Thank you very much, Barbara, for inviting me today.
Thank you for joining us. So today we're going to talk about climate change. And I believe that some of our listeners may already be wondering why we're doing so, because they probably know that EFSA's main remit is about food safety. So before we even start going into a more detailed conversation, could you please help us first understand what is the link between EFSA and climate change? How does EFSA connect to this very current topic?
Yeah, the reason why we are dealing with it is that most of the studies related to climate change and the food system are describing the effect of climate change on food security issues. So basically the food production for a growing human population. Very few studies are dealing with effects on food and feed safety, but not only these, also plant, animal health and nutritional quality. And that's why we are involved.
Thank you. Okay, so now we have clarified a little bit the link between EFSA, food safety and climate change on a more theoretical level. As you explained to us, there are different connections. So now I would be curious to, for example, have a few concrete examples of the potential effects that climate change could have directly on food safety. Can you talk about those?
Yes, I will mention just a few examples. I will start with effects on mycotoxins, on the emergence of mycotoxins, where EFSA has done quite some work in the past, in particular related to the emergence of aflatoxins due to climate change. And our scientists have developed and used a prediction model focusing on several scenarios of temperature increase. And they found that the most likely scenario we are going to observe, which is a temperature increase of 2 degrees, is going to create issues in relation to the presence of aflatoxins in mice in Europe. Another example I would like to mention is that of risks to plant health. Risks to plant health normally occur because of two factors, invasive species or vectors bringing different sorts of viruses with them. An example of this is the Bemisia tabaci, also called white fly in more colloquial terms. And again, our experts, our scientists have developed some predictive models showing that the area of establishment of this insect in Europe might increase because of temperature increase and also the population density. Another example I would like to mention is that of cyanotoxins in food and feed. Cyanotoxins are produced by cyanobacteria, which are a particular type of bacterium which behaves like an algae in the sense that performs photosynthesis. And our scientists and experts have again developed some studies and some models showing the effect of climate change on the distribution of such cyanotoxins and also on the toxicity of cyanobacterial populations. And the general outcome is that we might observe in the future an increase in the exposure to cyanotoxins, not only humans but also animals through feed.
Okay, so quite already a few examples you gave me there. And unfortunately quite alarming, and I can imagine that many of these toxins you mentioned could also have negative effects on human health. So definitely something to be considered. And you just made examples that could be considered as more direct on food safety due to climate change, but I also know that there are many other occasions in which climate change could affect possibly indirectly food safety that we sometimes don't even think about. Am I correct? And if so, can you tell us something about those?
Climate change may affect the transport pathways, fate, and, for example, bioaccumulation and elimination and exposure to toxic compound through rainfall events, for example. That's a possibility. The other possibility is that climate change may change the use patterns of pesticides and also veterinary drugs because of the invasion of different sorts of species. And it's important to note that this use of veterinary drugs could determine an increase in the risk of spread of antibiotic resistance. Another possibility is the impact on the robustness of the cold chain or in general on food hygiene issues associated to the different steps of the food chain. I would also like to mention the interaction between climate change and other drivers, in the sense that climate change is a driver and as such never acts in isolation. It always interacts with other drivers. For example, in determining or stimulating the uptake of drivers like circular economy practices. And here I'm referring in particular to the example of water scarcity and drought, which is a quite hot issue nowadays, since we have just observed in Italy, in Spain, and in France particularly warm winters. So this could stimulate the use of, for example, sewage water or wastewater, different stages of the food production chain, the production, or also in the other steps of the food chain. And this is water that sometimes could be of questionable quality. Another driver of relevance is the uptake of circular feeds. We know that feeds production is associated with a relevant environmental impact, biodiversity losses, and generation of pollution. Therefore, the trend is toward changing the sources of feed, and among these changes we are also considering possible circular feeds like those originated from food waste or former food products or food processing byproducts. And then the last thing I would like to say, which is very, very important considering the EFSA's remit, for all what I've said so far, it's clear that we must take climate change into consideration when carrying out risk assessment, as climate change may substantially impact its relevance. Not only, we also would need to adopt holistic approaches where not only climate change is taken into consideration, but also other stressors together, like, for example, pesticide use.
Yeah, quite a lot of additional examples of indirect effects. So I would have not thought that climate change could actually impact IMR. And you just showed us that that could actually be the case, or even thinking about the use of sewage water. So it's really interesting. And I would ask you many different questions, but you talk specifically about water. So we know that oceans are also possibly going to be very much affected by climate change. Just to make an example, according to experts, ocean water peak heat records in April. Can you tell us more about the implications of climate change on oceans and what this could mean for the future?
Yes, the oceans play a very relevant role in relation to climate change, because the oceans can both mitigate climate change, but also they can be heavily affected by it. Mm-hmm. When I think of mitigation of climate change, I'm referring particularly to the role played by algae in absorbing and sequestering CO2 and producing oxygen. Mm-hmm. On the other side, in terms of negative effects of climate change, I would mention, for example, the oxygenation of ocean waters, increase in sea surface temperature, acidifications, and ice melting, for example. So it's fundamental to guarantee or to contribute to guaranteeing a good health of the ocean. Also because we have relevant drivers in recent periods, the use of ocean resources for economic growth that needs to be sustainable.
And you told me some time ago also that there could also be geopolitical effects due to climate change.
Yes, if we think, for example, of the effect of climate change of melting the ice coverage, for example, in the Arctic, this could have relevant implications because new commercial routes could open there, previously unused or unexplored because of the ice coverage, and also the use of relevant resources like oil, gas, of several sorts of metals there. And of course, the opening of such of these possibilities may have some geopolitical implications.
Everything is so interesting and also a little bit worrying. The oceans are really important from many different points of view, and being them affected by climate change so could also lead once again to food safety concerns. So can you explain how this could happen, and can you also talk to us a little bit about a project carried out by EFSA specifically in this area?
The reason why we are interested in this evolution of the use of the oceans is because it may indeed have effects on food safety. I'm thinking here of two particular aspects associated with climate change. The first one is the increase in sea surface temperature, which triggers an increase in the duration of the stratification of the water column. And the second one is the increase of the occurrence of floodings in estuarine waters, which could determine a higher outflow of nutrients for a variety of organisms like algae, microscopic algae, or marine bacteria, some of which are toxic in the sense that they produce toxins. Climate change may change the distribution of these organisms and may increase the concentration up to levels that are sometimes referred to as blooms, but also have an impact on the toxicity of these blooms, and that's a little bit more difficult to predict. But we are trying to do that, in particular in a project we have been developing the past few years, dealing with ciguatoxins. And ciguatera. Ciguatera is the most common intoxication due to marine biotoxins in the world at a global level. It's typical of tropical and subtropical areas, but starting from 2004, outbreaks of ciguatera have been recorded also in Canary Islands and Madeira, so in Spanish and Portuguese Macaronesia Islands. So we have launched a project and funded a project together with the Spanish Food Safety and Nutrition Agency, aiming at characterizing the risk of ciguatera fish poisoning in Europe, but also to measure the levels of ciguatoxins in algae and in fish in Europe, and develop analytical methods to quantify it. Recently, now we are in a follow-up stage for such a project, and in the follow-up we have also added a relevant part related to the development of predictive models of the distribution of the organisms, dinoflagellates, which are responsible for the production of these toxins, and the emergence of ciguatoxins in fish, again under climate change scenarios.
Okay, so if I understand well, the poisoning happens because people are consuming fish that consume the algae. Okay. So, wow. So it's truly fascinating to see how everything is so interconnected, and one small change could lead to several others in different and even apparently non-related areas. I think this is what we normally call complex systems, right? So when it comes to food safety, is there work in place to try and anticipate such complex dynamics and prepare in advance for emerging risks?
Yes, indeed. We are living in a world which is normally described with a variety of attributes like volatile, complex, and so on. They stress the fact that besides complexity, this world is characterized by changes which are more and more rapid. So that's the world where we need to take decisions, where we need to perform our assessments and to contribute to food safety. This may seem a little bit discouraging, but still we can implement approaches, innovative approaches to handle for such complexity and to being prepared to what the future may bring to us. We are actually doing that in EFSA through the implementation and piloting of environmental scanning approaches, meaning that we are trying to investigate what's around the food system, and in particular developing foresight approaches, where foresight is a methodology which brings together science of the future or literacy about the future with creativity. And we try not to predict the future, of course, which is impossible, but to just understand possible scenarios where the future could develop. And we need to do it in a participatory way, and indeed that's what EFSA is doing. We are bringing together different, first of all, partners, organizations, but also different stakeholders impacted by the specific subject matter. Examples of the applications of these principles to the EFSA's remit are, I could give two. The first one is a foresight exercise we have run related to circular feeds, which are again connected with climate change because of the reason I've explained before. And the second one is a recent project about future uses of the oceans. The oceans are going to be more and more used in terms of its resources in the future because of the uptake of these blue economy practices. If we think, for example, of evolution of trade and transport, but also the possibility of generating food packaging from ocean resources and the possibility of extracting, as I was mentioning before, different sorts of minerals, but also, of course, production of food and feed from the ocean. So how is it going to evolve in the future, big also in consideration of climate change, and what kind of effect this may have on food and feed safety, not only on food and feed safety in terms of emerging risks, but also in terms of identification of areas where EFSA should develop an expertise, should develop capacity in the future.
Thank you so much, Angelo. I look forward to the final outcomes of all these projects. We're almost at the end of our episode for today, but we've learned so much from you. What you say, it's fascinating, also a bit worrying, but we've seen, that there are activities in place that should help us face the challenges ahead. Before we close, I have just one last question for you. As you may know, on Science on the Menu, we like to ask our guests for a personal anecdote about the topic of the episode. So do you have anything you want to share with us? For example, I don't know, were you always interested in climate change, or is this more of a recent passion?
I must admit that besides a pure scientific interest, I've been driven by emotions. I've started to work as an oceanographer, studying the impact of atmospheric forcing like heat stress, wind, and precipitations on marine circulation systems and on the spatial and temporal distribution of those algae we were mentioning before, and the impact this has on CO2 absorption and climate change. Therefore, for me, it's like going back in time and feel young.
Oh, nice. So the passion was always there. It's
yes, yeah,
okay,
true.
An old passion. Well, we're happy you felt young with us today. I hope the effect spreads to me too. Let's all feel young. Thanks so much again, Angelo. I hope you enjoyed being with us, and I hope that our listeners enjoyed it too.
Yes, I did enjoy it, and thank you, everybody.
Feel free to subscribe and follow Science on the Menu, and stay tuned for the next episodes.